Okay, so this is the Unit Exam 5-1, number 8 prep video. So number 8 is going to be, if you look in your packet, these are problems like number 8. So you'll be told that a function is continuous, and you will be given a table of values for the function. You will be asked to use a left endpoint or right endpoint Riemann sum to estimate the average value of the function. So here's the directions which I'm going to follow. First, express the average value of the given function over the given interval as an integral expression. Okay, so basically, guys, you just need to know the average value formula. So I made up this example. You don't have to take notes if you don't want. You could just watch. So here is the table of values I'm given, and this is the interval that they want the absolute, or not the absolute, the average value over. So you just need to know the average value formula, which is this. Okay, so this would be part A. Okay, and I'm going to talk about, I actually have like a proof for the average value formula, and it's not a hard proof to follow. It's really kind of neat. So I thought of it in the car the other day, actually, and I'm going to show it to you guys during class sometime. But so the average value is this. So the average value, average value of g of x is it's 1 over, let's see, okay, b minus a, I'll give the formula first, times the integral from a to b of g of x, okay? And then a and b are just the endpoints of the interval. So I just plug in -7 and 8. So it's going to be 1 over 8 minus -7 is 15 times the integral from -7 to 8 g of x dx. Okay, so you're going to get some points just for doing that. So we have expressed the average value of the given function over the given interval as an integral expression. This is called an integral. So this is an expression involving an integral, so it's an integral expression. And then what we're going to do is estimate the average value of the function by using a left endpoint Riemann sum or a right endpoint Riemann sum. So here I'm saying left endpoint for the first 3, practice right endpoint for the next 3. I'll do a right endpoint sum here, and then at the end of the video I'll show you this over here, which I did, which is a left endpoint sum. So I'll just like show you what it is so you can see it. Let me check the time. We're on a 2-hour delay schedule, and 12:28. Okay, so I'm good. I think I can do it. All right, so here are the values that they're giving me. So I'm going to plot them. So right here, I've left myself like, enough notches. -7 is the leftmost endpoint, 8 is the rightmost, and then I put -1, 2, and 3, and 0 in between because that's what they're giving me. And then my highest y value is 10, so I did 10 notches. And then I'm going to go like this. You don't have to do it like this, but I'll show you something that helps me. So for -7, I need an output of 10. So I just like take a ruler, go all the way up to 10, and then go like that. Okay? But I'm not a great artist. That's why that helps me. And then for -1, 0. For 0, I'm referring to these. Okay, so for an input of 0, I get an output of 4. For an input of 2, I get an output of 7, so 4, 5, 6, 7. Again, this just helps me because I'm not a good artist. And then for 3, an output of 9. So 3, and then up to 9. And then for 8, an output of 5. Okay. Now, it is extremely important. Do not take this word for granted, guys. You will be told that a function is continuous. If it's not, so continuous means no breaks, no asymptotes, no holes, all of that. The limit exists everywhere. So the reason that's important is because the continuous thing allows me to connect these dots. Now, and I'm going to just connect them in the simplest way possible. It is true that like between these 2 points, the graph might go up and then down and then woo, it might be kind of crazy, but I'm just going to connect the points in like the simplest way possible. Okay, and you could make it like a little bit curvy if you want. Okay, so there's that. Okay, so the continuity is what allowed me to connect the points, and this is just an estimate. These are the only points for sure I know their location of. Everything between could be different, but there we go. All right, so now I'm going to use a right endpoint sum to estimate the average value. Well, guys, in order to know the average value, I need to know what this is. Okay, so I need to estimate this. If I'm going to estimate the average value, I need to estimate this. And what is this? This is the area under the curve. Okay, so area under the curve. So that's what I'm estimating. And the directions are telling me here to use a right endpoint sum. So you're going to use, and they're not going to tell you how many subintervals because you just use the subintervals that you have. -7 to -1, that's a subinterval. -1 to 0, 0 to 2, 2 to 3, 3 to 8. Those are the subintervals. All right, so my first subinterval is from -7 to -1. All right, and then my next subinterval is -1 to 0. And then my next subinterval is 0 to 2. I'm just alternating colors. And then, you don't have to do it like that though. 2 to 3. And then finally, the last subinterval is 3 to 8. Now the fact that we're doing a right endpoint sum means that I'm going to be using the right endpoint of each subinterval for the height of the rectangle. So this is kind of a weird situation here because really this is a lot of area, but since I'm doing a right endpoint sum for this first subinterval, this is the left endpoint, this is the right endpoint. And this right endpoint, its y value is 0. Okay, so if you look up here, the first height that I'm using, so I'm using the right endpoint, so this is my, I'll call that H1, that's my first height. So this is not a great approximation because my first rectangle is really just this flat line. Okay, now for the next subinterval from -1 to 0, left endpoint -1, right endpoint 0. I'm using the right endpoint for the height. So I go to the right endpoint up to the graph. So this is going to be the height of this rectangle. Okay, so I use this right endpoint, so that's the height of my second rectangle. Okay, third rectangle. there's the base from 0 to 2, left endpoint, right endpoint. So I go from the right endpoint up to the graph. Okay, so I used this endpoint, so that's the height. So 7 is the height of the third rectangle. And then for the fourth rectangle, from 2 to 3, right endpoint. All right, so this is height 4 is 9. Okay, so this is height 4 is 9. And then this will be height 5, because I'm going to use 8 for the last one. Okay, so here is the last subinterval. Left, right. Use the right one to go up to the graph. So this is you could just tell this is a huge underestimate. Okay, for one thing, this first rectangle is like just a flat line, so we're not even counting any of that. Here we got a little bit of overestimates, but this is an underestimate. It looks like the underestimate parts are more than the overestimate parts. So I think altogether this will be an underestimate. So now for the area under the curve, we've got to add up all of the rectangles. So we're going to have 5 rectangles. Rectangle 1, 2, 3, 4, 5. All right, and I'm going to do height times base because that's how, when we do our summations, like the limits of the sums, when we do those, it goes height times base. So I'll do height times base instead of base times height. So for rectangle 1, this one, the height is 0. Okay, so height 1 is 0. Times the base from, this base is 6, so that's 0. Rectangle 2, the height is 4. Okay, so this green rectangle, the height is 4. So 4 times, but the base is 1. Rectangle 3, this third one, the height is 7. And the base is 2. And then rectangle 4, the height is 9, and the base is 1. And rectangle 5, the height is 5, and this base here is also 5. Okay, and then you add all of these up. So 0 plus 4 plus 14 plus 9 plus 25 is 52. Okay, so the sum of all of those is 52, which means that this area under the curve, so this means the exact area under the curve, but we're estimating it. So I go like this for approximation. So this is approximately 52 square units. Okay, but we're not done because, so here I've estimated the area under the curve, but I want to estimate the average value, which is this. Okay, so maybe I'll be like, therefore, average value of g of x on -7 to 8 is 1 over 15 times this integral, and this is approximately 1 over 15 times 52, so it's, oh sorry, you can't even see, so 52 divided by 15, so it's just, that doesn't even simplify. Okay, now just let me show you the difference. If I did a left end point sum, All right, here's my same graph, but it would look very different. Let me put them side by side, if you can even see them. You can't. Just a minute. So, sorry, my class is starting. Someone's trying to get in. Just a second, guys. Okay. So let me put these, can you see it then? Like side by side. This is a left endpoint sum. Riemann sum. This is a right endpoint Riemann sum. So this time I'm using, instead of having the heights being the outputs of the right endpoint, I'm having the heights being the outputs of the left endpoints. Okay, and then I ended up with something totally different, much bigger for the estimated area, and then the average value was 8. Okay guys, so hopefully that helped.